All right, guys, we are continuing with graphing trig functions. This video specifically is from Trig 5.6 and Pre-Cal 4.6. It is the two graphs of tangent and cotangent. So before we go to do an example, I'm going to refresh your memory on the differences between these two and the other four. These two graphs are the only two that have exceptions to the rules. So I'm going to bring out the worksheet that we worked on in our first video in part 1. Tangent and cotangent both look like the x cubed graph. Tangent looks like the positive one, and cotangent looks like the negative one. Okay, so it goes downward left to right. Two things in common between both is that their first and fifth points, when we do our 5 points, will be drawn as asymptotes, not an actual part of the drawing. Okay? The middle point will be where we hit the midline. And then the other 2 points, the second and the fourth, will be where we match up with or down with our amplitude. Okay? Now, the biggest difference for both of them is that their cycle is, instead of 2 pi over b, it's a single pi over b. That's the first big difference. And then the second big difference is only for tangent, and that's that tangent is the only trig function that's centered at the origin. So what does that mean for our chart? Exactly. So either 0, or if we have a horizontal shift, when we do tangent specifically in our 5 points, instead of going to point 1, so it says all except for tangent, we'll put our 0 or horizontal shift on point 3. This does not apply for cotangent, only tangent. Okay? And the other one that I mentioned, our cycle, remember we said 2 pi over b for the 4 that we worked on? Tangent and cotangent specifically work with pi over b. Their cycles are shorter than the other 4. Okay? So, I've made those 2 main points here for the cycle and for the 5 points. Let's start looking at this problem. Everything else should feel the exact same. So, I'm working with a trig function of tangent. It is positive, so I know this one's going to look like the x cubed graph, the positive one. Okay? And because it's tangent, I know that I'm going to put my horizontal shift on point 3. Now, I don't see a number in front of tangent. When that happens, what can I assume my amplitude is? Beautiful. If nothing's there, you can assume tangent is being multiplied by 1. Okay? My cycle, again, this is my other big difference. Instead of 2 pi over b, it is pi over, what is my b? Also 1. Exactly. When we don't see a number in front of a variable, we can assume it's multiplied by 1. So my cycle's length is just pi. Horizontal shift, opposite sign. So it's going to be negative. And then c divided by b. The nice thing about this question is that because my b is 1, it's really just my c. Okay? So again, I like to put my horizontal shift immediately once I find it on my point. And because it's tangent, I'm putting it on point 3. Vertical shift, I can see it out here. I have a minus 3 on the outside. So negative 3 is where my midline is going to be. And my increment is 1/4 times the cycle, which gives me pi over 4. So now we're ready to work on our 5 points. Because I'm starting with point 3, remember my increment is how much I move to the following point. What do you think we're going to do with our increment to get to point 4 and 5? We're going to add the increment. How about to get to point 2 and 1? We're going backwards, so we're going to have to subtract the increment. Okay? So for point 4, I'm going to say negative pi over 2 plus pi over 4. I need a common denominator. So I say negative 2 pi over 4 plus pi over 4. What does a negative 2 and a positive 1 give me? Good, negative 1 pi over 4. Okay. And now one more time, negative pi over 4 plus my increment, which is pi over 4. That one cleans out nicely. And I get 0. Okay. So we added to get to 0.45. Now we're going to subtract negative pi over 2 minus pi over 4. We have to get this common denominator again, or if you catch that you're doing the same work, you can jump straight to knowing that negative pi over 2 with a common denominator would be this negative 2 pi over 4, because you already did that work, okay? So negative 2 pi and negative 1 pi give me? Good, negative 3 pi. And now negative 3 pi over 4 minus your increment. Negative 3 pi minus pi gives me negative 4 pi over 4, or you can just call that negative pi. It is totally up to you. All right, so now that we have our 5 points, it is time to draw. Before I put my graph, I'm going to analyze my 5 points. Do you see that all of them are negative and I end up at 0? That means I'm going to want to drive my y-axis to the right so that I have all of my numbers on the left. Now, also analyze a little bit so you don't go crazy on your paper drawing this huge graph and then squishing, your drawing on one side. I'm going to go down 3 for my midline, and then I'm going to have an amplitude of 1. So I'm going to be in some pretty negative numbers, okay? So I'm going to draw my x-axis a little higher than usual. Okay, you don't have to do that, but again, it'll help your spacing on your notes, okay? All right, so my midline is at negative 3. Okay. Now my amplitude is 1, so from negative 3 going up 1, where do I land? Good, negative 2, and down 1, negative 4. Okay, that is 1 point already on your quiz or test. Your second point comes from your 5 points. So the last one is over at 0. My last one over here on the left is negative pi, or negative 4 pi over 4. And then you can keep filling the rest out. Okay, there goes your second point. Now my last point goes to the drawing, okay? I know that on tangents of my 5 points, my outside 2 are asymptotes. Bless you. So these are asymptotes. Okay? So the first and the last, which is going to be a little hard to see here because it's on the y-axis, are my asymptotes. Okay? Now the middle point, the third point, is where I hit my midline. Okay? So my midline's at negative 3. My middle point is negative pi over 2. Okay? And now this one, because it's a positive tangent, is going to look like an x cubed graph. That means this needs to travel up on the right and down on the left. My second and fourth point need to match with the amplitude. So if I'm going down on the left, negative 3 pi over 4 needs to line up with my amplitude down at -4. So this part will go downward. And then this one that I draw upward, my fourth point, -pi/4, should match up with my amplitude over at -2. And there is your tangent graph. All right, so we are moving on to our cotangent graph. And I'm specifically giving you a negative cotangent graph because I want you to see how sometimes you might get stumped when tangents and cotangents are negative because they can start to look like each other. So, for example, if I were to do a negative tangent graph, it flips upside down and now starts to look a little like cotangent. So don't overthink it too much. Just like we did in the last question, draw yourself the sketch and then forget about it until the end when you go to draw it, okay? So, the trig function I'm working with is cotangent, and it is a negative. So, if cotangent usually looks like a negative x cubed, the one we're working with is that graph, but just flipped. So it does end up looking like a tangent graph, okay? So our amplitude here is 2. Again, if you choose to write positive or -2, doesn't matter, as long as you understand the concept that we're moving 2 up and 2 down. My cycle, remember this is where one of my changes happens. Cotangent and tangent have a cycle of pi over b. So in this case, my b is 2. Okay? My horizontal shift is opposite the sign, so it's going to be positive. And it's c, which is pi over 2, divided by b, which is 2. I'm going to have to do a keep change flip here. Pi over 2 times 1 over 2, which gives me pi over 4. Where do I place my horizontal shift on a cotangent? 0.1 or 0.3? 0.1. Remember, tangent is the only one that gets put on 0.3. This is one of those tricky things, guys. On cotangent, that part stays the same, okay? You do put your horizontal shift on 0.1. Again, tangent is the only one that you put your horizontal shift on 0.3, okay? Vertical shift, I have a +2, so that +2 is going to be my midline. And my increment is 1/4 of my cycle, which gives me pi over 8. Okay? So now, since I'm starting at 0.1, I'm just going to add my increments all the way down. So from pi over 4, I'm going to add pi over 8. I'm going to need that common denominator. A 2 pi over 8 plus a single pi over 8 is 3 pi over 8. And if my increment is 1 pi over 8, what am I going to get at my next point? 4 pi over 8, and then 5 pi over 8, and then, right. So again, once you catch that pattern, you can skip the rest of the work, okay? I'm going to do it for the sake of your notes. All right, and now we have our 5 points, okay? So when I go to draw my graph, I notice that all my 5 points are positive, so I can draw my y-axis over here on the left. And then my midline goes up 2, and then I'll be moving up and down 2, so it doesn't really matter how far down I put my x-axis, okay? So the first thing you draw is your midline. My midline is at positive 2. Okay. My amplitude is also 2, which means I'm going to go 2 up, landing on, good, on 4, and then 2 down, landing on 0. There's your first point on your quiz or test. My next point is to draw my 5 points. So I have that's just me drawing my tallies. So my midline was at 2, and then I went 2 tallies down to 0 and 2 tallies up to 4. Alrighty, so now that we have our 5 points, now I'm going to be drawing the negative cotangent. Here's where I need to peek back. It should end up looking like a positive tangent. There are asymptotes for this one as well. Same rules as tangent. So my first and last point here are asymptotes. So that means pi over 4 is an asymptote. And 6 pi over 8 are also asymptotes. Okay. My middle point, the third point, is where I hit my midline. Okay. So my middle point was 4 pi over 8. I'm going to put that dot on the midline. Okay. And again, this is going to look just like the last image we drew, even though it's a cotangent because of that negative. So it means I'm going to go up on the right, and this fourth point will match with this amplitude. And then down on the left, and this second point will match down with this amplitude. Don't worry about how pretty your image looks. As long as you have those numbers correct, you are fine. And that's our tangent and cotangent graph.